In this video, we will cover some basic aspects of Agilent MassHunter Qualitative Analysis software. The interface of this software is highly customizable and can be adapted for the current use. As we can see in the View menu, over 20 different panels can be shown or hidden. For the most purposes, we will need Data Navigator that lists all the opened data files and all the extracted chromatograms and spectra, enabling them to be selected, shown, hidden, or removed. Then we will need Method Explorer that provides access to all aspects of data analysis, and Method Editor that enables configuring each section. Then we will also need chromatogram results, UV spectrum results, and MS spectrum results that display the extracted chromatograms and mass and UV vis spectra. Additionally, if needed, we can display integration peak list that lists all the integrated peaks in the selected chromatogram, and MS spectrum peak list one that tabulates the selected mass spectrum. All the windows can be rearranged as needed. A window can be made floating, snapped to the side of the screen, snapped to the side of a selected window, or tabbed with another window. And of course resized as needed. This is done by just dragging and dropping the title bars onto the displayed docking indicators. Different window layouts can be saved and loaded using configuration, window layouts, save layout, or load layout. Thus we can have more than one layout adapted to, for example, processing spectra from single data file, then another one for accessing numerous data files, comparing their chromatograms and reading peak areas, and so on. We open a data file or multiple data files by selecting File, Open Data File, or just clicking on the appropriate icon. So in this case we will select these two data files. If we have already defined file open actions, for example specific signal extraction, integration, we can check the appropriate box, and these actions will be performed after the data file is loaded. So we load our data files. They are now listed in Data Navigator. By default, total ion chromatograms are extracted and displayed in Chromatogram Results window, and also listed in Data Navigator pane. If needed, we can extract other chromatogram types. So we go to Method Explorer, Chromatogram section, and we go to Define Chromatograms option. And now the appropriate option will be opened in Method Editor. In Type field, we can see different types of general MS chromatograms, so total ion chromatogram, base peak chromatogram, extracted ion chromatogram. Types for specific MS experiments, SIM, MRM, neutral loss, and we can also extract chromatograms acquired by other detectors, such as diode array. Additionally, we can extract instrument curves, such as pressure or mobile phase composition. For example, we can extract base peak chromatograms. We can indicate this is the first order mass spectrum of scan type recorded under both positive and negative ionization. But in this case, we don't actually have to do that. All the changes in extraction parameters are entered by using change or by using add if we want to extract several different types of chromatograms from the same data file. The extraction is performed by clicking on the appropriate option. If several data files are loaded, the software will ask which of them should be used for extraction. So in our case we will use both. And now we have 4 chromatograms, 2 total ion chromatograms and 2 base peak chromatograms. We can also define a subset of M over Z range for the data to be displayed. For example, 200 to 400. Again, change. We will do that only for positive mode, for example. And now if we compare chromatograms, they are not identical, so some peaks are now excluded. If we want, we can ask the software to integrate the chromatograms immediately after the extraction. If the data file contains several scan segments or cycles recorded under different conditions, we can specify them in the Advanced tab. So we can extract only signals recorded under the specific fragmentary voltage or collision energy, for example. In that case, it may also be necessary to use cycle sum. Excluded masses can be used to remove some M over Z values and or M over Z ranges from chromatogram. For example, to remove M over Z's that correspond to artifacts. Note that it cannot be used with total ion chromatograms, only with other MS modes. We can exclude, for example, these M over Z's. Can change, extract. So if we compare these two chromatograms, we can see that some ions, some peaks are now removed because some ions are now excluded. Now we have multiple chromatograms extracted. They can be shown overlaid or listed. If the chromatograms are listed, we can select how many of them will be visible in the window. If they are overlaid, we can set scaling to realistic, so each chromatogram is on the same scale, or to normalize them to be comparable regardless of the actual signal intensity. Then we use scale to largest in each chromatogram. So now they are comparable. If we need, we can show or hide chromatograms at will using Data Navigator. So all the extracted chromatograms are listed in this pane. A visibility can be manually set by checking or unchecking the chromatograms. Additionally, we can show only the highlighted items by using this button. We can add more highlighted items, or we can just show everything. When selecting items in Data Navigator and Chromatogram Results windows, common Windows shortcuts apply. For example, Ctrl-A for selecting all, Ctrl-clicking for selecting item by item, click, Shift-click for selecting a range, and so on. If needed, chromatograms can be permanently deleted by highlighting and just pressing del on the keyboard or using delete option. Note that the chromatograms will just be removed from the software representation, and they can actually be extracted again, and the data in the data file will remain unaffected, so we cannot actually change the data file content. We can also unload the unneeded file from software by right-clicking and selecting Close Data File. Now, how to manipulate the chromatograms. To zoom in a region, just use right drag to draw a box around the needed region, and we have a zoomed chromatogram. To zoom out, use the Auto Scale X and Y axis tool in the chromatogram results toolbar. To fit the zoom region by Y-axis, we can use Auto Scale Y-axis option. The additional way to zoom and pan chromatogram is by dragging the axis. Left drag pans it, while right drag zooms it in or out. If we need to change chromatogram color, for example, if we have several chromatograms and we want to differentiate them, we can choose Define Color from the right-click menu. To integrate the chromatogram, several methods are available and are accessible through Method Explorer Chromatogram window. For example, we can use MS Chromatogram. For each integrator, many options are available, including filters based on peak size, peak count, and so on. So we integrate chromatogram just by pressing this button. Integration results, that is a peak list, are displayed in Integration Peak List. The content of this list can be, for example, copied, if needed, into, for example, Notepad. For each peak, numerous parameters can be shown. We can choose them by right-clicking on the table header and selecting Add Remove Columns. So we can actually display retention time, area percent, MS base peak for each chromatographic peak, start and end time, width at half maximum, height, and so on. Symmetry. If needed, peaks can also be manually integrated by selecting the appropriate tool in Chromatogram Results. This is Manual Integration tool. Then by left dragging, we can change the peak integration by defining a new baseline. Note that these integration filters still apply. So if we define that only large peaks should be integrated, the manual integration will be ignored. Peaks can also be annotated by using the appropriate tool in Chromatogram Results. So we can add image, for example structure, or text. So we can add some comment. And we can define numerous parameters. The chromatograms can also be copied and pasted into other applications. So when the chromatogram results window is selected, we can just click copy to clipboard or use Ctrl+C, and then we can paste chromatogram into another window, for example into PowerPoint. In addition to mass chromatograms, we can also extract UV-Vis chromatograms. So in Define Chromatograms window, we choose Other Chromatograms and type of detector DAD1. Now several types of traces can be extracted. Signals, A, B, C, and so on, as defined in the acquisition method. We can also extract total wavelength chromatogram, so the entire absorbance will be plotted, or we can display extracted wavelength chromatogram for a defined wavelength range, say 300 nanometers with 8 nanometers bandwidth, so it will be 260 to 340, and with 550 nanometers with 100 nanometer bandwidth as a reference. Again, change and extract, and we get two chromatograms. We can zoom in a bit. Now, if we zoom in and integrate the same peaks, for example, this one, we can see that MS chromatogram lags about 0.04 minutes behind DAD chromatogram. So this is DAD chromatogram. This is because it takes some time for effluent to physically cross distance between DAD and MS. To autocorrect this, we can use Adjust Delay Time option in chromatograms. So we enter MS retention time and DAD retention time. We calculate the difference, and then by clicking Adjust Delay Time, the lagging chromatogram will be shifted to correct for the delay. Both MS and UV-Vis spectra can be easily extracted by double-clicking on a selected point in the appropriate chromatogram. However, to compensate for short-term noise, it is better to average several spectra, which is done by selecting a range by left dragging. Now for that, the range select tool, which is default, should be selected. And then double click on the marked range or use Extract MS Spectrum option. So now we have averaged spectrum from a selected range. So we can do the same for the UV. To correct for a background signal, we can select a background region, for example this, then extract the background spectrum, select the peak spectrum, and then click on Subtract Background Spectrum. So it will be done automatically. Alternatively, we can just select the peak spectrum, click on Subtract Any Spectrum, and then click on Background Spectrum. We can do that both for MS and for UV. So now we have a bit more clear spectrum. Another way to extract purified spectrum is to use a peak select tool. it is only usable when we have integrated peaks, such as this case. Then we select the peak select tool and we just click on extract peak spectrum. So in this case, the software will automatically take average spectrum of the peak, average spectrum of the baseline, and subtract them automatically. Again, all the extracted spectra can be shown, hidden, or deleted through the data navigator. In the case of mass spectrum, MS spectrum peak list 1 lists different useful information about the spectrum, including of course the spectrum itself, but also some other characteristics which are especially useful if we have high resolution MS and automatic interpretation. This table can of course be copied and pasted, for example, into Notepad or Excel. If too many or too few peaks are labeled, this can be changed by selecting Adjust Peak Threshold. So only the peaks with intensities above the selected level will be shown. As with chromatograms, spectra can also be zoomed, panned, annotated, and so on. For the purpose of MS interpretation, M/Z differences can easily be read and labeled by using data mass caliper. So we just drag from one to another peak, and we can see that the peak difference in M/Z is in this case 22, which indicates sodium proton and sodium adduct. By double left clicking on the spectrum, extracted ion chromatogram can be displayed, or with UV, extracted wavelength chromatogram. So in this tutorial we covered only the most basic options of the Agilent MassHunter Qualitative Analysis software. In addition to those, there are many advanced options. So the software is also capable of chromatogram deconvolution, that is finding peaks, extracting their pure chromatograms and spectra from the MS chromatograms. If the chromatograms are recorded by high resolution MS, it is capable of determining the molecular formula from the molecular mass. It is also capable of library search by using its own procedures or by interfacing with NIST MS Search program, and so on.